Now, in a previous lesson, we looked at how AS path prepending can be used to control inbound traffic. As it turns out, longest prefix match can also be used to control inbound traffic. Suppose that ASA owns 10.1.0.0/16, and it might advertise that prefix out both of its upstream links, and that route might similarly be advertised further upstream. Now, of course, as we know from a previous lesson, given the advertisement of one prefix upstream, ASD is going to pick one best BGP route along which to send traffic back to A. But let's suppose that ASA wanted to balance that traffic across its incoming links. Well, in that case, ASA could actually advertise routes for two more specific prefixes, effectively splitting the /16 in half. So in addition to advertising 10.1/16 across both links, ASA might advertise 10.1/17 on the top link and 10.1.128.0/17, the other half of the /16, on the bottom link. Now, if either link fails, the covering /16 will ensure that the prefix remains reachable by one of the two upstream links. But because longest prefix match wins, the traffic for 10.1.128 would now traverse the bottom link, and the traffic for 10.1/17 would now traverse the top link, effectively sending traffic for half of the prefixes along the top path and traffic for the other half of the prefixes along the bottom path. Although we just explored a perfectly good reason to deaggregate a contiguous prefix, it turns out that sometimes autonomous systems may deaggregate larger prefixes unnecessarily. A report called the CIDR report, which is released weekly, shows autonomous systems who are advertising IP prefixes that, at least according to observation, are contiguous and could be aggregated. For example, the top offender for the week of December 12, 2013 was AS6389. This single autonomous system is actually advertising more than 3,000 unique IP prefixes. The CIDR report's analysis suggests that with appropriate aggregation, this autonomous system could instead advertise only 56 unique IP prefixes. Now, this might be overly optimistic. As we just explored, there are perfectly good reasons to deaggregate a contiguous IP prefix into multiple smaller contiguous IP prefixes. But nonetheless, the report shows that there are probably a lot more IP prefixes in the global internet routing table than there could be if ASs took full advantage of aggregation.